using the x, all right? And now let's do an example problem and show you how to figure out how far something goes. Okay, I'll fold this paper here real quick. Why don't you take a second and copy down this problem right here, all right? Solving for dx, or range, in other words, an example problem. So I'll read it and then you could copy it down. A pool ball leaves a 0.6 meter high table with an initial horizontal velocity of 2.4 meters per second. Determine how far from the edge of the table that the ball will land on the floor. So how far is the ball going to go before it hits the floor? All right, we're going to calculate dx in this problem. All right, so copy down the words right now. Pause it and do that, and then we're going to solve the problem together. Okay, so hopefully you copied that down. Now we can go ahead and solve the problem together, all right? Okay, step one is you need to draw a diagram, all right? So you could pause it right now and draw this diagram right below where you copied the problem. Okay, so as we read the problem, we want to fill in this diagram. So in the diagram, you should have it drawn already. We could see in the problem that there are two numbers that we could fill in. All right, the diagram is just a way to make a list of our givens. All right, we're going to write down two numbers and we're going to write a question mark in the diagram. All right, so let's start reading. A pool ball leaves a 0.6 meter high table. Since that word high is height, all right, I think we're measuring a distance because it's meters, and height is a distance vertically, or in other words, a distance in the y direction, all right? So that number, 0.6 meters, that is a dy, write it in there, all right? And it leaves with a horizontal velocity of 2.4 m over s. That m over s tells me, if we look back in our notes, m over s means it's a velocity, all right, in the x direction. So it's shot to the side. Vx is 2.4 meters per second. So we figured out that that is dy and that is Vx. And we filled that in our table there, in our little diagram we have set up. I'm going to set up the same diagram for every problem this week, all right, with you guys. So it's just a way to list your givens. You can make a list of 1, 2, 3 if you want, but I like doing it in a little picture, okay? Now where are we going to write the question mark is next. Determine how far from the edge of the table that the ball will land on the floor. How far is it going to go in the air before it lands on the floor? So that is our last variable that's left over, dx. We're going to write that as a question mark. We're going to solve for that using our equations that you copied down before. All right. So, don't go away. There you go. Step 2 is we have to make a XY table. Okay, and I want you to write this down. There are two calculations needed in each problem. So you have to use both equations every time you do a problem. You need to do two calculations. You need to do one calculation in the y and one calculation in the x. So please now draw this table called our XY table. I did put the y on the left. I know that seems kind of weird, but our first calculation is going to happen in the y, and our last calculation is going to finally get us dx in the x column. So in the y, what equation are we going to use? Well, remember we have our dy equation with gravity in it, so we're going to use that equation in the y. Let's copy it down. dy equals a half gt squared, and in the x we'll use our other equation, dx equals vxt. I just copied down the equations, one for the y column, one for the x column. We will always use this equation in the y column. We will always use this equation in the x column. We will always do our first calculation in the y column. All right? So let's plug in what we know from our list over here, okay? Well, we see dy, we could plug that in as 0.6. A half, g is always 9.8. All right, and then we have t squared. All right, I might need a bit of a calculator here. Use my computer. So what's our first step? Well, we could take the half and the 9.8 and multiply those together. We get 4.9 t squared. All right, and then we got to get t squared all by itself, so we're going to take the 0.6 divided by 4.9 and cancel the 4.9 on the right side, and we'll have t squared all by itself on the right side. On the left side, we could do the math. 0.6 divided by 4.9 gets you 0.12. I'll round it there. And the last step, get rid of the squared, take the square root of both sides. Familiar with that, right? And when you take the square root of both sides, you get 0.35, and since it's time, the unit is seconds. That's not our final answer. We want to know how far the ball goes, okay? But you need to write this down. I'm going to write it in a different color so that you're so clear on this. I know you want to solve for dx. That's your final answer. That's how far the ball goes. But our rule is always solve for time. It's not a great colored pencil. Always solve for time first. Before you get what you're really needing, go in the y column, use that equation, and get time. And then you'll use that time in the x column to get what you really need. So we always said you need two calculations. The first calculation will be in the y column, and you'll get time. The second calculation will be in the x column. All right? So if you want to write your first calc is here in the y, and your second calc is here in the x. All right, first calc, get time. Now we're going to plug that time in the other equation, okay? And we're going to solve for dx is what we really are looking for. How far does the ball go? So we could plug in the 2.4, and the time was 0.35. Multiply those two together, and you're going to get how far the ball goes. You could do it on your calculator. Check my answer. 0.84 meters. Almost a whole meter away from the table is where it lands. This is pretty cool that you could figure out if you know how fast something is going and how high up it's shot from, you can know exactly where it lands. And, you know, try to do a lab on that if we could. Alright guys, so we got dx, we answered our question, how far away from the table does the ball land? Remember, there are 3 variables, okay? The problem is always going to give you 2 of them. Make a little diagram and fill in the 2 you're given. In the problem they gave us how fast and how high up it was shot from. We had to figure out how far it went, okay? So draw this little diagram, fill in 2 of the variables, and write a question mark next to the third so you know what you're trying to solve for. And then set up a x and a y table, all right? Start out with this equation in the y, solve for time first, plug that time in the other equation in the x, and you could get what you're looking for, which was how far it went. All right, guys.